Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now going to answer question number 3 from the January 2021 Statistics S1 paper. This question here is about normal distribution. The weights of packages that arrive at a factory are normally distributed. So the weights are such that they are normally distributed with a mean of 18 kilograms and a standard deviation or a variance of 5.4 squared. So standard deviation is 5.4, that means the variance is 5.4 squared. That's how you write this notation for normal distribution. It says find the probability that a randomly selected package weighs less than 10 kilograms. So normal distribution follows this kind of shape, which is this bell-shaped curve. Okay, this is the normal curve. And in the middle of this is the mean. Okay, so I'll make this a bit bigger. So in the middle of this, right in the middle here is the mean, on the median and the mode, all in the middle. So the mean is 18. So this is 18 in the middle. This corresponds to the z value of 0. The z value tells you how many standard deviations that value is away from the mean, whether it's above or below the mean. So the mean itself is 0 standard deviations away from the mean. So this is like the standardized value, you could say. We want to find the probability that a randomly selected package weighs less than 10 kilograms. Now 10 kilograms is on this side of the mean, somewhere over here. Just say that's 10 kilograms over there. Okay, so we need to, first of all, we need to find what the z value is for this. And we need to find the probability that it's going to be somewhere less than this area. So we have to try to find the probability it lies in this area where it's less than 10 kilograms. So the first thing we need to do is standardize this value. So we want to find the probability. We want to find the probability that the weight is less than 10 kilograms. Okay, which is equal to the probability that z is less than. Now we've got to standardize this 10. To standardize this 10, to find how many standard deviations it is away from the mean, we use the formula z equals x, the amount you're trying to standardize, minus the mean, mu means the mean, over sigma, which is the standard deviation. So here we're going to have x, which is 10, minus the mean, which is 18, over the standard deviation, which is 5.4. We don't use the variance here, we use the standard deviation. That tells you how many standard deviations away it is from the mean. So you can just put 10 minus 8, which is minus 8. Sorry, 10 minus 18, which is minus 8, divided by 5.4. And that gives us minus 1.481. 1.4814814841. So that's going to give you the probability that z is less than minus 1.481481481. We just need the 2 decimal places because that's what our table will have. So we need to find the probability that z is less than minus 1.48. So we're going to find the probability that z is less than minus 1.48. So how do we do that? Well, let's go to the table. See, the fact that it's minus means it's going to be a negative. It's going to be less than 0, so it's below the mean, as we can see. So it's minus 1.48. So that means 10 is minus 1.48 standard deviations below the mean. How do I find what this probability of something being less than that is going to be? Well, we go to the tables. Let's go to the tables. Here we have the probability distribution table, and we're going to use this one over here, where we know the value of z is minus 1.48. So we're looking for this value of z less than minus 1.48. So we're looking for this area here. Now, unfortunately, we don't have any z values which are less than 1. They're all positive, because this only tells us the standard deviations above the mean, which is from 0 on this side. But what we can do is use the fact that this is symmetrical. So I can take the same distance here on this side. Okay, this line here, which I've drawn, which it doesn't want me to catch for some reason. Okay, so I can take the same line on this side, and I can just draw it on the other side. draw it on the other side. Let me just move it. Okay, so the same line on the other side, symmetrical. Okay, so that value there would be positive 1.48. That's all, positive 1.48. And I can find positive 1.48 in my table. Okay, you can see 1.48 is over here. Let me just highlight it so we can see. This is what the value is of z equals 1.48. But what does this number on the right of it mean? This tells us the area under the curve to the left of 1.48, below 1.48, 0.9306. So that's the area from here all the way back to the beginning. That's what the area is. Okay, so what the area is that gave us is all of this area here, which is 0.9. Oh, I've forgotten now. Let's go back down and see. 0.9306. Okay, but I don't want this area. I want the area on this side. This is the area I'm looking for, because why? This area is the same as the area that we're looking for, because it's symmetrical. So if I take this area that I've got and I do 1 minus 0.9306, that's going to give me the area I need, which is this area, which is the same as what I'm looking for. As you can see, the whole area is actually 1. It's like the probability of the whole thing is 1. And the area that we're looking at in the table is the area to the left of these z values. Okay, all of these areas are to the left of these z values. And we want the area to the right of it. So we do 1 minus the area to the left. We get the area to the right. So therefore, I need to find this value. So let me just set the working out in a good way, just so that you can see how we can do that. So I know that the probability that z is less than minus 1.48 is the same as the probability that z is greater than 1.48. So this is the same that the probability that z is greater than 1.48, and the probability of that from our table can be found by doing 1 minus the probability that z is less than 1.48. This is what I can find in my table. This was the value of 0.9306. 0.9306. So this is 1 minus 0.9306, which equals, we're going to have 1 minus 0.9306, and that gives us 0.0694. 0.0694. That's the probability that the weight is less than 10 is equal to this. There we have the answer to part A of the question, and now to part B. Okay, part B says the heaviest 15% of the packages are moved around the factory by Jemima using a forklift truck. Find the weight in kilograms of the lightest of those packages that Jemima will move. So let's take our table, and I'll take this line with it as well, because that will be useful. Let me just try and paste it over here if it wants to come here. Yes, it does. Okay. So let's just say that the heaviest 15% of the packages are moved by Jemima. So let's say that this represents here 15% of the packages. The heaviest 15%, the ones on the heaviest side. That means that this side has got 85% of them, right? Okay, so I want to find the value of, remember this is the mean, which was 18. I want to find what this value is, okay? And I know that 15% of the data is bigger than it, is above it. Okay, so again, I can go to my tables, but this time, you see, I have a table on top here, which might be useful. Whenever they give you like the probability or the area value, then what you can do is you can use the table on top and see, will I find that particular area? Because the table on top, the first number gives you the probability, and the second number gives you the value of z, where that probability is to the right of it. This is like the area under the curve, and this is like the z value for which that area is to the right of it. So I want to find the z value such that there's 15% to the right of it, which is 0.15. So I have to look to see, is 0.15 in my values for probability? And it is. It's right here. Okay, this is the value that I'm looking for, 0.15. Okay, so I know that the Z value, such that 15% of the data to the right of it is 1.0364. So then I can say that is 1.0364. Over here, this value of Z is 1.0364. That's the Z value, but I want to find what the actual value is. All right? So I know that the weights were normally distributed with a mean of 18 and a standard deviation of 5.4, or you can say variance of 5.4 squared. Was that correct? Yes, it was. So I also know that to standardize the score, you take the other way around. To standardize the score, the Z value, which is the number of standard deviations above or below the mean, is equal to X minus the mean over the standard deviation. Okay, I know the number of standard deviations above the mean it has to be, which is the Z value. That's 1.0364. And I have to find what the actual value is, minus the mean, which is 18, over the standard deviation, which is 5.4. So if I rearrange this, I'll end up with X equals 18 plus 1.0364 times 5.4, and that will give me the what I'm looking for, the score that I'm looking for. So I'm going to take 18 and add to it 1.0364 times 5.4, and that will give me 23.596. 23.596. Does it tell me how to round it? No, so if not, we'll say that's going to be 23.6 kilograms. So that's the smallest weight that she'll be given, the lightest weight in kilograms that she'll be given to move, because it represents the lightest one, which is still 15%, one of the heaviest 15% of the packages. The lightest of the heaviest 15% of the packages. Okay, so that is part B done. Now on to part C. One of the packages not moved by Jemima is selected at random. Okay, so now let me just get the curve back here. Give me a second. Okay, so one of the packages not moved by Jemima is selected at random. Find the probability it weighs more than 18 kilograms. So the ones that are not moved by Jemima are the ones that are in this category here, which are less than this weight here. So this is the category of the ones that are not moved by Jemima. All of these. Okay. All right. So we want to find the probability that it weighs more than 18 kilograms. Okay. So over here, what we're looking for is this region over here. We're looking for the region, okay, such that it weighs less than 18 kilograms, more than 18 kilograms. So it's going to be in the region between these two. That's the region that we're looking for. Why is that not? Okay, that's the region that we're looking for, in this region here, because 1 second. Yeah, this region here. Okay, because that's the region which is between the weight that she can, that's more than 18 kilograms and up to what she can carry. So we need to find the probability of something lying in this region here. That's what we need to find. But there's a condition here, because basically what we have is we have a situation, okay, where we're considering the sample space of the packages not moved by Jemima. So it's basically saying, what's the probability that it weighs more than 18 kilograms, given that it's, one of the ones that is the ones that Jemima did not carry. So that was less than 23.6 kilograms. Okay, so it's like given that the weight is less than 23.6 kilograms. That's what they're asking us to find here. So we need to find this area here, which is quite easy because we know that this is 0.15 and from here to there is 0.5. So this area is 0.5 minus 0.15 because it's up to here 0.5. This is 0.15, so this means this is 0.35. Okay, and we have to divide that area by not the whole thing, okay, but by up to this point, which is going to be 0.85. The whole from there to there is what she doesn't carry, is 0.85. So this is basically, if we remember from our conditional probability, that this is going to be the probability that W is less than 18 kilograms intersection with the probability that the weight is less than 23.6 kilograms divided by the probability that the weight is less than 23.6 kilograms. So it's going to be the area that we discussed earlier, which is 0.35 divided by the area of the section which that she doesn't carry, that the other people carry. Jemima only carries the ones which are heavier than that because she's got the forklift truck. So they're only considering the rest of them, which is 0.85. So it's 0.35 out of 0.85, which is 35 over 85. 5 goes into 35 7 times, and 5 goes into 85. 1 remainder, that's 17 times. 5, 1, 3, 17. Yeah. So 17 over 7 over 17. Okay, so the answer here is 7 over 17. Okay, the probability that it weighs more than 18 kilograms, given that it's one of the packages not moved by Jemima, which is these. Okay, I hope that was clear. That's question part C. Now we're going to have question part D. It says here, a delivery of 4 packages is made to the factory. The weights of the packages are independent. Find the probability that exactly 2 of them will be moved by Jemima. Okay, so we want to find the probability that exactly 2 of them will be moved by Jemima. Okay, so now delivery of 4 packages is made to the factory. The weights of the packages are independent. Find the probability that exactly 2 of them will be moved by Jemima. So the probability that one of them will be moved by Jemima is 15%. And the probability that one of them will not be moved by Jemima is 0.85. So it's 85%. So there's 4 packages delivered. Okay, so we want to find the probability that exactly 2 of them will be moved by Jemima. Exactly 2 of them. So, for example, you're going to have, say, the first 2 moved by Jemima and the second 2 not. Okay, now we're going to look at all the combinations of this. All right, all the different combinations of how to arrange these in order, so that have all different combinations. All the different combinations we can have these so that you've got exactly 2 J's and 2 not J's. All the different ways of doing it. So let's have a look, all the different ways of doing it. So I could have, for example, the first 2 not delivered by Jemima, first 2 not Jemima and the second 2 Jemima. I could have the first Jemima and the last Jemima and the first 2 inside, not Jemima, and the other way around, the first not Jemima and the last Jemima and the first and the 2 inside Jemima. Then I could have, for example, Jemima, then not Jemima, then Jemima, then not Jemima. Okay, that's one I haven't done. And finally, I can have not Jemima, and then Jemima, Jemima, and then not Jemima. So these are altogether 6 ways of arranging these in a way such that we have different combinations of exactly 2 of each. It's like we've got 4 items, and what we have to do is we have to choose 2 of those items and find how many ways of choosing 2, how many different ways there are of choosing 2 of those items. This is what this is. This is like the combinations button. If you notice that this in your calculator will give you exactly the same, it will give you exactly the same value. If I press, we used this from binomial expansion in P2, but this is basically what we're doing. We're choosing from 4, 2. All right, we're choosing from 4, 2, all the different ways of getting 2. Like, for example, we could be considering this as Jemima's from 4 altogether, 4C2, and you can see it gives us 6. Okay, so this is a way of working that out in a quick way, if you understand about combinations. Right, so these are all the different combinations of having 2 J's out of 4 items like this. So there's 6 different ways. So if we find the probability of one of those ways, for example, the first way, it's going to be 0.15 times 0.15 times 0.85 times 0.85. And all of these will have those same numbers in them, all of them. Okay, you'll have two 0.15s multiplied by each other and two 0.85s multiplied by each other in all of these. So there's going to be 6 combinations of all of these. So I'll multiply this by 6, and that will give me my answer. So that will give me my answer, which is 6 times 0.15 squared times 0.85 squared, which gives you 0.0975375. 0.0975375. Yeah, so to 3SF, that's 0.0975, and that's the answer to part D of that question. Okay, that's the answer to part D of the question, and we have finished this question now. Question 3 from S1, January 2021, and other questions from this paper you can find in the playlist, which will appear somewhere over here. Other questions from this topic of normal distribution you can find in this playlist that should appear in this area. You can subscribe to my channel by clicking on this link, and you can find another past paper of P2 on the card that's been appearing on the top of the screen. Thank you for watching, and see you soon.